PCB electronics has different dust, temperature, and humidity controlled clean rooms like with laminar flow workstations to limit the dust particles from entering the microcircuits. The hybrid microcircuits are fabricated in a clean room environment. Entry to the labs are restricted and are strictly monitored. Before entering these areas, everyone is required to wear anti-static aprons, masks, gloves, and footwear and pass through a high-pressure air shower to dust off any foreign particle. Let us now take you through our hybrid microcircuit chip manufacturing process. Initially, screen printing technique is used to print the conductive tracks or resistors on a ceramic substrate. One substrate can have multiple circuits depending on the size of each circuit. We use different screens for different layers. Once these tracks are cured, the thick film resistor layer is printed. For different value of resistors, different pastes are used. Value of the resistor depends on the length, width, along with the resistivity value of the paste. The thickness of each layer is closely monitored and controlled. Once all the layers are printed, the substrate is placed on a belt that takes it through the multi-zone furnace. This process is called firing, and it forms a solid pattern of conductive and resistive areas on the ceramic substrate, after which the substrates are taken through a process called laser trimming, where the resistor value of each resistor gets trimmed within the tolerance limits provided in the design. Automated laser trimming machines measures the value of each resistor and trims the surface area such that the resistor value increases closer to the typical value. Then the laser scribing process cuts the multi-circuit substrate into different pieces, finally processing them into individual microcircuits. All these parameters in the print, fire, trim, scribe process are controlled using the design and process document. All records are maintained for traceability. Chip capacitors are then soldered by using solder paste printing and reflow soldering, which melts the solder paste into a solder joint. Finally, a visual inspection is conducted to ensure proper connection between the components and the tracks on the substrate. The connection pads of the chip are connected to the substrate using the gold wire bonding technique. Gold wire bonds of different thickness such as 0.7 mil, 1 mil, 1.5 mil, 3 mil are used for these connections. The thickness depends on the typical current value expected to flow through these connections. Each of these bonds are pull tested using a bond pull tester. All the bonds are visually inspected under microscope for proper ball formation, loop and bond quality on the substrate. 100% conformance is mandatory to ensure reliability and performance in the long term. Visually inspected and passed substrates are then attached to a gold-plated Covar metal package using thermally conductive epoxy. The substrate edge pads get connected to the package pins using appropriate wire bonds. The packages get functionally tested and all parameters get documented. Only functionally approved microcircuit packages are processed further. Packages are cleaned and visually inspected and go through a 72-hour stabilization bake under vacuum at 150 degrees centigrade for outgassing and removal of moisture. After vacuum baking, substrates are seam sealed in a nitrogen environment with moisture level less than 100 ppm using resistance welding or laser welding. Sealed packages then go through fine leak test and gross leak test, followed by 100% functional testing, which is expected to have a 100% yield with zero defect. Finally, functionally approved hybrid microcircuits get the needed marking including code, name, part number, customer name, date, month, lot code, manufacturer code, etc. as necessary, after which the HMCs are ready for dispatch.